Hi friends, in the previous sessions we have looked about what the linked lists are, how the singly linked lists are created, and then last session we have seen how any node can be inserted into a singly linked list at any position. So now let's check how a node which is no more required to be in the linked list to be deleted. So it's only matter of changes to be made in the pointers. So let's look at an example. So we have a linked list with first node having a value 10, second node having value 20, third node having value 40, and fourth node having a value of 30. So this linked list we had just created in our previous session by inserting a node with value 40 at this given position. Now we would like to delete this node which has got a value 40. So what we need to do is if we are already at the node prior to this, so that means if we are already at this node, then there is direct thing we need to do is whatever is the address of the next node of this which is to be deleted, that is address of this node has to be just written here, and this connection automatically gets disconnected and the memory allocated for this has to be freed. Otherwise we need to look for this node. So we are no more interested in reaching this node, we are only interested in reaching this node. So from the beginning we just look at is the first node we are looking at is what we want to delete. So we are trying to delete a node with value 40. So we just look at start from the head and see whether the head's value is 40. If yes, this has to be deleted. So if we delete this, then this automatically should be made head. So one option is if this is 40, then this node has to be deleted. Then the simplest thing would be call the second node as a head of the linked list and then delete this. So that is not the case. So in this example, we are trying to delete a node with value 40. So we just look at this start from the head. Is the node contain the value we are looking for? We are looking for 40, but what we have is 10. So no. So we go to the next node. What we are looking for? We are looking for 40. Is it that? No, it is 20. Then we go for the next node. What are we looking for? We are looking for 40 and we have 40. Yes, now we are in this node. So what can I do? I have to do something. This has to be connected here. But the problem is, once I come here, I don't know how to go back. Therefore, instead of searching for the current value, let me start searching for the next value. So first thing is if this is the node we are trying to delete, then just directly check if that is the node having the value we are looking for. No, then instead of looking for the value of current node, you start looking for value of the next node. So we are currently here and we look for value of the next node. Value of the next node is 20. Is it so? No. Then let us move here. Now what is the value of the next node? Value of the next node is 40. Yes, so that is what we wanted. Where are we? We are here. So from here we make a connection directly to this. How this connection is made? So we are here we know that the next node is the one which contains the value we are interested in. So we would like to delete this node. So before deleting this node, I just check what is the address written here in the next of this node. So it is talking about this node. So this address is copied over here. So once this address is copied over here, this no longer exists, and this connection is automatically made just because the address of this is here, and this address, if it is copied here, then now it starts pointing to this location, and now this node is no more required, so we can release the memory used for defining this node, so we can just release or free the memory. That's what we need to do. The actions to be done. So one, if it is the first node, then just start with the head, look at its value. If it is so, then the second node you call as head and delete this node. If first node is not there, then I have to start looking one step in advance, because I have to stop prior to the node which I have to delete. So if I want to delete the third node, then I should stop at second node. So how to stop at second node? Then instead of looking at the value of that node, you start looking at the value of the next node. So value of the next node means you have current node, currents next is this. So currents next value or data is what you are talking about. So if this is current, then currents next is this node and its data is 20. If it is 40, no. Then instead of calling this as current node, move to the next step and start calling this current node, and current node's next node is this, its value is 40, yes, then stop this movement, and now we have reach this position. So we call this as current node, and then the current nodes next is what we are interested in. So current nodes next node is this. Its next is talking about this. So in the current nodes next, we should write current nodes next address. Then this link gets connected, and then later we need to delete this node, free the memory. So that's so once this node is connected, automatically this gets disconnected. So once this is deleted, then we get this. So first node is 10, second node is 20, this 40 is deleted, and after 20, direct connection is made to 30. So let's look at the code, how this is done. So here, as usual, we have defined a node which is a structure having one part as data, which is an integer, another a pointer to the next node, and then we have some push functions just to create what is a linked list, and then we are trying to delete the list. So to delete the list, we give where the list begins, the reference of the head, and we want to say the which node to be deleted. So that node will be identified by the value which we are saying by key. So we just create one temporary pointer, and that is currently pointing to the head of the linked list, and if the point temporary whatever we are talking is not null, that means the linked list exists and the headers data itself is the key, then what we need to do is the headers next So whatever is the header's reference is there, you just call as a temps next. So whatever is the next node, so start calling the next node itself as the head, and then free this node and then return. If that is not the head, then you start looking for the next one. So what is that? You start looking for the one where you get a current data as the key. So we keep checking. So whatever is the current location, we just look at current location. If it is not equal to key, then the current location, current node, we call it as a previous node and move to the next one. That means one step behind, we are having a reference as previous. So we just move to the next node, and this way we keep moving until we reach the location where the data in the temp is the key and the previous temp was stored in the uh, pointer previous. So if you just look at this, so as we keep moving, this was the first one which we called temp, and if this doesn't have the required data, then we call it previous, and then move this and call the next step as the temp. This is the previous. So is it containing the required value? No. Then we call this as temp and move one step ahead. And then is this having the value we are looking for? Yes, we are having a value which we are looking for. Therefore, we come out of that loop. So when we come out of that loop, this was the temp and this was the previous. So that's what we have here. So when we come out of the loop, then we have the temp whose data is equal to key. That's why we come out of that. And then the previous one was stored in the previous loop, and that is stored as a previous. So when we come out of that, then what we do is previous next is equal to temps next. So if you just look at what is this is temp, this is previous. So previous next, which one should be previous next? It is same as temps next. So temps next is showing this. So the same thing should be shown by the previous. So that means this node should point to this one. So how to know this? This is pointed by a node called temp, and this node is being called previous. So previous next is same as temps next. Then we get this new link created, and finally we free the memory allocated for temp. So that's how it is done. So to check as an example, so we push 7, then 1, then 3, then 2. So we this way we are pushing. That means first 7 goes in, then 1 goes on top of that. That means 1 comes before 7, then 3 comes before 1, then 2 comes before 3. So at the end, what we have is 2, 3, 1, 7 is the way the data is stored in the linked list 2317, and finally we are trying to delete the one whose key or the data is 1. So 2317, if 1 is deleted, then we should get a new linked list which shows 237. So let's just check this. Is that what we are getting? So before deletion, it was 2317 as we look in the code. So 7 was inserted first, then 2, then 3, then 2. So 2317 was the order in which it was there. And if we delete 1, then it should be 2, 3, and 7. So after deleting 1, it is 2, 3, 7. So let's try something else. So if we delete 3 instead of 1, then we should get 2317 before deletion, but after deletion we should get 237. So let's check that. So 2317 and 3 is deleted, then we get 217. So that's how deletion is taken up through this. So it's only insertion, deletion, and all are just the game played by making the connections or the links created appropriately. So in insertion, we add a new element and then make appropriate connections. In deletion, we find the node to be deleted and make appropriate connections so that the node will be either inserted or deleted and so on. So that's how the insertion and deletion in a linked list can be done. So many more issues to be discussed in the coming sessions. So keep watching. Thank you.